A new study from scientists at La Jolla Institute for Immunology, LJI, gives researchers a guide to neutralizing Lassa virus using a trio of rare antibodies isolated from survivors of Lassa virus infection. The virus causes Lassa fever, a disease that strikes up to 300,000 each year and typically starts with flu-like symptoms, but can lead to severe illness, death, and long-lasting symptoms, such as deafness. For pregnant women, Lassa virus is especially dangerous. Nearly 90% of infections during pregnancy are fatal. LJI scientists can now show exactly how a cocktail of 3 human antibodies can block viral infection. These antibodies may prove valuable in upcoming clinical trials for Lassa therapies, and the LJI team plans to use their new map of the Lassa virus surface glycoprotein to design a much-needed vaccine. We now know where these 3 therapeutic antibodies act and how exactly they act, says Catherine Hasty, Ph.D., an LJI instructor and the director of the Antibody Discovery Center at LJI. The findings were published in Science Translational Medicine as a cover story on October 26, 2022. The research was led by the Sapphire Lab at LJI, including instructor Haoyang Li, Ph.D., Hasty and Professor Erica Allman Sapphire, Ph.D., in collaboration with Luis Branco, Ph.D., of Zalgen Labs LLC. The Power of Neutralizing Antibodies. In 2017, Hasty and her colleagues in the Sapphire Lab, then at Scripps Research, published the first ever structural images of the Lassa virus glycoprotein. Lassa uses glycoproteins to enter host cells and initiate infection. Hasty's glycoprotein structure gave researchers an idea of what they were up against. This hope became reality when research partners at Tulane University and Zalgen Labs LLC isolated a promising group of Lassa-fighting antibodies from the blood of Lassa fever survivors. Collaborators from the University of Texas Medical Branch went on to test a cocktail of 3 neutralizing antibodies in non-human primates. This antibody therapy, called AREVIRUMAB3, proved 100% effective in treating Lassa fever, even in animals with advanced disease. This was a groundbreaking finding, says Sapphire. The dogma had been that antibodies would not be protective against Lassa virus. When it came time to test the cocktail in human clinical trials, the researchers faced a problem. The U.S. Food and Drug Administration was not prepared to launch clinical trials until the researchers could uncover the mechanism that made the therapy so effective. Fortunately, the Sapphire Lab had the tools and expertise to reveal these molecular details. Li led the effort to produce a native Lassa glycoprotein. Thanks to advances in protein production and 3 years of perseverance, Li's version of the glycoprotein was a copy of the real thing and could be recognized by all 3 antibodies used in AREVIRUMAB3. This area of the glycoprotein is where 3 molecules, called protomers, come together to form a trimer, a kind of twisted trefoil, as Hasty describes it. Lassa would normally use this region of the glycoprotein to bind with receptors on host cells. But Li's structure shows how a single 8'9F jumps in and binds to all 3 protomers simultaneously to block infection. The structure is really a beautiful illumination of how this antibody essentially mimics the host receptor to block the glycoprotein receptor from binding, says Hasty. It's an absolutely gorgeous structure to see. Meanwhile, the neutralizing antibody called 12 1F binds to just one protomer in the three-sided trimer. At the same time, copies of antibody 37.2D target Lassa virus by binding in a way that anchors adjacent protomers together. With 37.2D on the scene, its entry machinery is locked up, unable to function. Lassa has another trick. It shields itself using a thick coat of human carbohydrate molecules. Like a wolf in sheep's clothing, says Sapphire, Haoyang structures clearly show how these potent, protective antibodies breach or even utilize the carbohydrates to target and neutralize the virus. The findings fill a critique. In fact, just this year, the Sapphire Lab has published 3 articles on anti-Lassa neutralizing antibodies, including this paper. The other 2 investigations were published in Cell Reports, Enriquez et al. Cell Reports 2022. PMID, 3561358, and M-Bio. Buck et al. M-Bio 2022. PMID, 35730904. This body of work now offers the first ever full epitope map, revealing every vulnerable target of the Lassa glycoprotein. Says Sapphire. We now have a very clear idea about the neutralizing epitope surface and the requirements needed on the glycoprotein for antibody binding and recognition, adds Hasty. This study was supported by the National Institutes of Health. Grants U19AI 142790. R01AI 141251, R01AI 132223, R01AI 132244, R21AI 145374-03, and a Swiss National Science Foundation Early Postdoc Mobility Fellowship, P2EZP3_195680. A cocktail of protective antibodies subverts the dense glycan shield of Lassa virus. Science Translational Medicine, 2022. 14, 668, doi. 10. 1126, Sci Translamed. ABQ0991 La Jolla Institute for Immunology. New Lassa fever therapy may be on the horizon. 3 rare antibodies, combined in a cocktail, are effective in fighting Lassa virus. Science Daily. New Lassa fever therapy may be on the horizon. 3 rare antibodies, combined in a cocktail, are effective in fighting Lassa virus. Science Daily. https://ift. TT, MWWFNLD. Accessed October 26, 2022. Thanks for watching. Please subscribe my channel for more videos.